Hi everyone, today we are going to be talking about group level designs or designs for group comparisons, but that is in contrast to individual level designs or case level designs or individual designs where you just have one participant. We'll be talking about those next week. In group designs, you have multiple participants, and you're going to figure out a way to study them. So let's talk about this. So why do we use group level designs? Well, when we're concerned about sort of group level outcomes rather than individual client successes, lets us compare between interventions and control groups, which we often want to do to see if a new treatment works or works better than an existing treatment. And really, this is sort of how we build knowledge. This is how we build evidence for evidence-based practice, that kind of thing. So a couple of weeks ago, we talked about selecting participants, and we talked about sort of two big categories of how we select participants. There were random sampling techniques, and there were non-random sampling techniques. And if you remember, sort of the point from that video was that random sampling techniques, although they're tough to do, typically produce a more representative sample. It typically results in a higher quality research project, a project with fewer sort of vulnerabilities or flaws. So if we have a high quality sample, we want to make sure we have as well a high quality series of observations to study that sample. So there's sort of two big categories of group level designs. There's cross-sectional designs, and then there are longitudinal designs. And they are exactly like they sound. In a cross-sectional design, all data are going to be collected at one point in time, and in a longitudinal research design, data are always collected at two or more points in time. So a quick example of a cross-sectional design is like a political preference survey. So, for whom will you be voting in the upcoming election? When pollsters go out and do that, they survey a whole bunch of people at one point in time. They tabulate the results, and then that's sort of what they present. In a longitudinal design, you might survey people once, and then a month later or something, you survey them again to see how things have changed. And there's literally a million things you could try to, you could want to see a change in. You might be studying change in opinions, or change in psychopathology, or change in even something like income or something like that. So two big categories of group level designs. Depending on the research question, longitudinal designs are typically more rigorous or more robust. That's not always the case. There are plenty of questions that are sort of well suited to cross-sectional designs, like the prevalence of a particular problem, or maybe the impact of a particular problem, sort of descriptive and exploratory kinds of things. But typically, if you have a longitudinal design, you're looking at a more robust study. So the point of most research, or sort of the big goal, is to sort of prove causality, that one variable is responsible for causing one variable is responsible for causing a change in the different variable. But in order to sort of satisfy the criteria for causality, there's sort of a number of criteria that have to be satisfied in order to be able to conclusively say that that one variable causes another variable. So there has to be an empirical association between the independent and dependent variable. There has to be a temporal order or a time order. So you have to prove that the cause came before the effect. And that really only can be done with longitudinal research. That really can't be done with cross-sectional research, because you're measuring all the variables at the same time. There's a few others that aren't quite as important, but you have to be able to rule out other explanations, and you typically want to show a gradient. So if someone gets more of the cause, they show more of the effect. On the other hand, if someone gets less of the cause, they show less of the effect. But sort of without these, without satisfying these criteria, you really can't establish that one variable caused sort of another variable. So in group level designs, there's sort of another division that's useful to make. And so let me point out real quick. So the first division we're making is cross-sectional versus longitudinal. Longitudinal designs can then be sort of further subdivided into these three categories here: true experiments, quasi-experiments, and non-experiments or pre-experimental designs. So just to sort of orient you to where we are here, we're sort of drilling down into longitudinal designs here. So in experimental research designs, these are sort of the gold standard. Really is going to provide the strongest evidence strongest level of evidence about the effect of a cause, the role of a cause. Okay, so we're often using true experiments when we're studying interventions because we want to be able to give our clients good treatments. So true experiments are sort of what they do when they study vaccines. So they recruit a random sample of people, then they randomly assign them to either a condition where they get the vaccine or where they get a placebo. And we do that because it provides the most robust the most robust test of the potential therapeutic effect of a vaccine. Social workers do that same kind of thing for treatments for psychopathology, treatments for substance abuse, other kinds of behavioral problems. And the reason we do that is that we don't want to sort of waste time and resources with interventions that are not effective. So a second ago when I was talking about vaccines, I said the words random assignment, and that's a sort of key piece of terminology in the research design vocabulary. So random assignment is the key component of an experimental research design. There has to be people have to be randomly assigned to either a treatment condition or a control condition. Now, there are sort of two different kinds of control groups. There's a no treatment control group where there's sort of like an existing gold standard treatment group. But in general, you should know the difference between sort of experimental groups and control groups. In an experimental group, that is the group that's getting the new treatment or the thing that we're studying. The control group either gets nothing or usually if it's an intervention, they usually get the existing sort of standard intervention. So that lets us make a comparison about the level of effectiveness of whatever treatment it is we're giving people. So just to reiterate, the experimental group gets the treatment or the manipulation. The control group gets either no treatment or the traditional treatment. And so this idea of randomization ensures that there's no systematic bias or other, even unintentional bias that might skew the results. Note that we're really talking about. We've now sort of talked about randomization at two different points in a research study. So random sampling is different than random assignment. And if you could sort of devise a study where you had both a random sampling process for identifying participants, and then you randomly assigned those people to different treatment conditions, you would have a very, very robust study. And it can be done, it is done, but it takes a while, it's very expensive. But that is sort of that's the gold standard right there. If you can achieve that level of robustness, you're going to have a good study on your hands. So how do we assign people into groups? Well, you can toss a coin. Heads, you go into the treatment group. Tails, you go into the control group. You could roll a die, something like that. Typically, in large clinical trials, what they do is they have a computer program that does it for them. It's a pretty sophisticated algorithm, but at the end of the day, it's really very similar to sort of flipping a coin, something like that. Sometimes they do this thing called matching, where they match participants in the treatment and control groups on certain characteristics to ensure that there's no chance of randomization error. But I am mainly concerned with the fact that you know about randomization and how we might do that. So as I said here, here's just a brief example of sort of the difference between random sampling and random assignment, and there's really not a good place for me to put myself, so I'll move myself here in a second. But random sampling ensures that we have a generalizable sample, right? We can generalize our results back to from our sample back to our population, and then here, I'll put myself up here. Random assignment is a way to ensure internal validity, a term that we're gonna talk about here in a second. So again, these are sort of different ideas, even though both use this idea of randomization. So let's talk about a couple of different types of true experiments. There's pre-test, post-test control group designs, post-test only control group designs, and then a Solomon 4 group. First, before we get to the actual pictures of the designs, let me give you a key for interpreting the letters. So the O that you'll see here in a second stands for observation. We use typically a subscript to denote the different points of measurement, pre-test, post-test, that kind of thing. The X stands for intervention, and then the R stands for random assignment. It would be good to know what these different letters stand for. That's something that might appear on an exam. Sometimes you also see that in journal articles where people will give a visual sort of depiction of the design that they used. So in a true experiment, you would have a true experiment that used a pre-test, post-test control group design. You would have you would conduct an observation at baseline. We call that a pretest. And that's a measure of the dependent variable prior to the experimental manipulation. And then you would perform a second measurement after the experimental manipulation or after you've administered the treatment to see how much that dependent variable has changed. We often call that the post-test. So here is this part right here. Here is a simple depiction of pre-test, post-test control group design. So we've randomly assigned people to either this A group, which is the intervention group, or this B group, which is the control group. Now, in this particular scenario, our control group does not get a treatment. But the intervention or experimental group does. And of course, which group would we assume is going to change more? Well, since we would hope that since the A group gets the manipulation or the intervention, we would hope that they change more, whatever sort of variable that we're measuring. Now there is sort of an additional layer of sort of quality that you can institute, and that's called double blind, and that's when neither the researcher nor the participant knows which condition they're in. So typically in vaccine trials, you're able to double blind them. So you've got a nurse, administering an injection or something like that, and the nurse will not know whether they're administering an injection or a placebo. Or a vaccine or a placebo, and then the participant doesn't know either. Why do we like double blinding? Well, because then the person delivering the intervention doesn't know what it is they're doing, and they don't accidentally reveal something to the participant. So it's just sort of a way to control some unintentional bias. So here's an example of a pre-test, post-test control group design. On the other hand, but the difference here is that both groups get a treatment. The one group just gets the traditional or alternative intervention. So what we would hope is that the experimental intervention produces a bigger change than the traditional treatment. That would tell us that this experimental treatment is better than the traditional treatment. You often see these designs in, especially in social work, like in treatment studies. So we might want to enroll people into, say, an alcohol treatment study. Well, if you identify people with an alcohol problem, you can't withhold treatment. That would be unethical. So what we'll do is we'll assign people to either the existing gold standard or some new treatment that we're working on developing, and that gets around any ethical issues of withholding treatment. So post-test only control group design is it just eliminates that pre-test, and you're only observing people at post-test, and then what you do is you compare the group that got the intervention to the group that didn't. Why would you do a post-test only control group design? Well, sometimes the pre-test has the effect of causing a change in the variable. So you want to you would use a post-test only control group design when you're concerned about the effect of the pre-test causing a change. So this is typically considered a weaker design because you don't have that pre-test. But again, you do use that when you're worried about the effect of the pre-test. So to get around whether or not there's a pre-test interaction or a test treatment interaction, a man named Solomon developed the four-group design, which is depicted right here. So you have the experimental group that gets the pre-test and the post-test. You got a group that gets the pre-test and the post-test, and then a group that gets the treatment and the post-test, and then a group that just gets the post-test. So if there were no effect of this pre-test, we would see this group change the most. This A group. If they're wait, did I say that wrong? I think I said that wrong. So if there were no effect of the pre-test and it was all due to the intervention, group A and C would change the most, and they would change equivalently. If there was an effect of the pre-test, group 2A would end up changing the most. If the intervention was not effective at all, you'd see groups A, B, C, and D sort of getting the same kind of score. So Solomon four-group designs, you don't see them often because they take a lot of participants and a lot of resources, but they are useful for ruling out effects of a pretest. So what exactly do I mean by sort of the effects of a pretest? Well, sometimes simply pointing out to people that there's a problem causes them to change that problem. And that happens sometimes with people with alcohol problems. They sort of take an assessment of their alcohol use, and they sort of come to this realization like, oh my gosh, I didn't realize that my drinking was having an effect on my social life and my professional life, and that realization leads them to change their drinking behavior. And while that's good, we really want our changes to be due to an intervention, not necessarily the test that we're the assessments that we're using. So true experiments are really tough to do in agency-based research. You can't withhold treatment from people. You can't randomly assign people. It's hard to randomly assign people to different conditions. The program typically can't change. The agency is responsible to funders and stakeholders and things like that. There's a huge difference, huge differences in skill level from staff. People who have been there for a very long time are often better interventionists. They're by virtue of having been in the field longer, they're usually more skilled than new clinicians. And then there's always the effect of professional judgment, people sidestepping rules of interventions and things like that in service of helping their clients, which is the appropriate thing to do. From the client's perspective, it just is harmful in the research perspective, or from a research perspective. I've also seen lots of staffers in agencies um, just give everyone the experimental treatment because they believe it's better, and sort of not give anyone the control condition, and then that effectively undermines the research as well. And then of course there's people who are resistant to participating in experiments and things like that, and that's fine. It just means we have to account for the fact that some people don't want to participate in research. So next big category of longitudinal designs are quasi-experimental. So the big difference between a true experiment and a quasi-experimental design is that there is no random assignment. So the groups are predetermined, or they're sort of naturally occurring. Okay. To really sort of have a good quasi-experimental design, you need to be sure that the two different groups are fairly equivalent. They're not considered as robust as a true experiment, but they still can be pretty powerful, especially when randomization simply isn't possible. Sometimes in quasi-experimental designs, you see these multiple time series designs. So in this kind of design, you're conducting 3 observations, then someone gets the treatment, then you're conducting 3 more observations. And so we would expect a big change sort of between times 3 and 4, and hopefully that would persist up through times 5 and 6 as well. So moving into the third category now, we get to these non-experimental group designs. These are still longitudinal, but there is no comparison group. Because this is sort of the classic program evaluation design. This is a one-group pre-test, post-test. So there's an observation, there's the intervention, and then there's a second observation. This is used in education research. This might be used in group therapy or group treatment. And as I said, this is often used in program evaluation research as well. We hypothetically, we didn't, but hypothetically, we could have done something. We could have used this design in our class. If I had given a test of social work research knowledge during the first week of class, that would be one way to sort of measure students' knowledge of social work research. The intervention or the treatment then would have been 14 or 15 weeks of social work research methods class, and then we could have repeated the same test, and we would expect that scores, of course, would be much higher at the post-test than at the pre-test. And what that would let us conclude was that our class was effective at increasing students' level of knowledge when it comes to social work research. Now, why don't we give students a test on the first day when they come to class? Oh, but that's pretty intimidating. It's not a particularly kind thing to do. If we did it, we'd have to be sure that the test on the first day of class, students knew it was purely for evaluation purposes. It wasn't for, it didn't count towards their grade or something like that. But there are lots of education researchers who do this kind of thing. So they test the knowledge of the subject at the beginning of a school year or an academic period or something like that. Then they teach a lesson, and then they give students that same test. And what we typically see is that students do much better because we can effectively increase levels of knowledge through a teaching treatment or a teaching intervention. This is a design you don't see a lot, and the reason for that is it's a bad design. This is a one-group post-test only, or they call it an after-only design, and that's so the intervention is delivered and then an observation is made. There's no comparison group, so you really can't make any judgments about the effectiveness of the intervention. And because you can't make those comparisons, that's why you really don't see this design implemented very much. It's just a sort of a bad design. The sort of way to rectify this poor quality design is sort of with a post-test only with a non-equivalent control group or a static group design. So this is the post-test only design that we saw a second ago, and then we just look for a comparison group. It's a highly imperfect comparison group, but just any old comparison group that we can get our hands on in order to facilitate some kind of comparison. Again, this is a very weak design. It's not widely used. You do see it in program evaluation research sometimes when people call in evaluators very late in the process of designing and delivering an intervention. And the program evaluators come in and they say, "Oh my gosh, we don't have a ton of options, but this is one of them." So, but you just don't see it very much. All right, so let's talk about this concept called validity. Now we've encountered the term validity before, and the place where we encountered that was on the week devoted to measurement. So measures have a statistical property that known as validity, and what it means in that context is essentially an answer to the question: does the measure measure what it claims to measure, or does the measure measure what it's supposed to measure? When we're talking about research designs, there's another form of validity that we need to talk about. Actually, there's two. So there's internal validity and there's external validity. Let me give you definitions for these real quick. So internal validity is the extent to which changes in the dependent variable are truly related to the intervention and not something else. So go back to these, any one of these designs, like this quasi-experimental group design here. Can we be sure that the change in the dependent variable, right, which would be measuring here and measuring here, can we be sure that the change is due to the intervention, or is it due to something else? And if it's due to something else, is it something we measured or something that we left unmeasured? So there are a number of threats to internal validity, things that could have caused a change in the dependent variable. A couple of threats, three main types of threats: non-comparable groups, endogenous change, and then external events. And let me give you definitions of these real quick. So non-comparable groups is exactly what it sounds like. Your intervention group and your control group are not equivalent. That could have been due to selection bias. It could have been due to something called mortality. People drop out of treatment for whatever reason. Those are the two big types of non-comparable group threats to internal validity. Then there's endogenous change. Endogenous change is sort of natural, developmental, perfectly normal change that occurs over the course of time. So what we don't want is for endogenous change to be responsible for causing the change in the dependent variable. The three forms of endogenous change are testing, maturation, and statistical regression. I am not concerned with whether you know the definitions of testing, maturation, and statistical regression, as long as you know what endogenous change is. That's really what's important here. And then there are external events that could cause change in a dependent variable. And the external events are things that happen outside of the study that could have changed subjects' scores. These are history effects, secular drift, and then instrumentation. The big one that you need to know here is history. Let me give you an example of that. suppose in January or February of 2020, you were a researcher. You started doing a study on maybe worry and stress, and you measure it once, and then you were going to give people an intervention, maybe to help them worry less or feel less stressed. And your intervention is supposed to start in March or April of 2020. Well, of course, we all know what happened in March or April of 2020, and that was really the emergence of the coronavirus here in the United States. So that wasn't part of the study, right? The emergence of coronavirus, obviously not part of the study, but it likely would have and did contribute to a growth or an increase in people's level of worry or stress. And so all of a sudden we have this event outside of the study that's affecting what it is we're trying to measure. In fact, I would hunch that if there were any studies, about stress or worry or something like that going on, in the earlier part of 2020, that experimenters or researchers would have seen just about no effective intervention, and it would be entirely due to history events. So external validity is the extent to which, so this is the other form of validity that we have to talk about. This is the extent to which our study is generalizable to other populations. So that's really what you need to know about external validity. If you know that internal validity is really the extent to which the intervention caused a change in the dependent variable, that's good. If you know that external validity is the extent to which a study's results are generalizable to another population, that's probably good. There are a couple of threats to external validity. Reactivity is one of them, and that's when a change in the dependent variable is induced by research procedures, the presence of a researcher, testing effects, that kind of thing. So let me again remind you here real quick, just the threats, and this is sort of what you would want to know for an exam. So there's validity related to a measure or an assessment, and that states, or that asks, does the measure what it claims to measure? There is then internal validity, which is a property of a research design, and that asks if the treatment is responsible for the change in the dependent variable. Then there's external validity, and that asks to what other populations can our study's results be generalized? How do we minimize threats to internal and external validity? Keep the time from pre-test to post-test as short as possible. We test subjects once, or use, you can scramble the questions in the pre-test and the post-test. We try to keep the time that it takes to complete the assessment as short as possible. We train our research assistants to interact with participants the same way. If we have a control group, we try to keep them involved. It's very rare that you see a no treatment control group, especially in social work research, because of the ethical issues. So oftentimes our control group might get sort of basic health education research, or health education interventions, which helps to keep them involved. So how else do we minimize the threats to internal validity? So we're cautious when subjects have extreme scores on assessments. We use random assignment when possible, and if we use random sampling, we'd also have a really robust defense against internal validity. So I know we've used validity a number of times here. And we've also used randomization sort of a number of times here in these different sort of contexts. But it's important that we understand that randomization can occur at two different points in a study. It could be during random selection, and then random assignment to a treatment or control condition. And then it's important that we understand that there's sort of three different kinds of validity in a research study. So there's the validity of the instrument or the assessment. Then there are threats to internal validity, which is a property of a research design, and threats to external validity, also a property of a research design. So I'll leave it there. Thanks for watching, and as always, feel free to get in touch if you have any questions.